Hello everyone, and today we will see the questions of two questions of Indian Forest Service Mains Examination 2021 that has been conducted on 5th and 6th of the March. I think I am the first one who is giving the solution of this exam. So this is the video number 2 of our Indian Forest Service Mains question series. First question, first video has been already uploaded in this playlist, okay, of the 2020 exam by Srishti Madam. So today I'm gonna solve question 2A1 and B. This question I'm not gonna solve because stress and curve for ductile material and mention salient points of the curve. This question we are solving since our first year of engineering, so we know all the question. We know all the how to write this question. Okay, stress and diagram for mild steel. So I'm not gonna solve this question because we know the solution already. So first question. So a beam is simply supported beam. Carries a uniformly distributed load, 50 kilonewton per meter. 50 kilonewton per meter. So let me write the given data first. So here given data. So simple uniformly distributed load, small w, that is 50 kilonewton per meter over the whole span. The section of the beam is rectangular, having the depth is 500 mm. So D is given as 500 mm. The maximum stress in the beam material is 150 megapascal and moment of inertia is 7 into 10 power 8 mm power 4. Find the span of the beam. So the maximum stress is given as sigma 150 megapascal and moment of inertia it is 7 into 10 to the power 8 mm power 4. And what we have to find what is the length. So this is a simply supported beam. Okay, I'm drawing the free body diagram with UDL or 50 kilonewton per meter, and we have to find out the length. We know the flexural formula M by I is equal to stress by Y. Y is what in this case, as here it is given maximum stress, so Y will be D by 2 because maximum bending stress is on extreme-most fibers. So M value, we have M by I is equal to sigma by D by 2. Okay. Now M value, that is maximum bending moment. So one thing that I would like to suggest you that please keep remember in all the, or you can say that you can formulate, or you can say that you can remember all the maximum bending moment equation or formula for different case, like for simply supported beam with point load, UDL, cantilever beam with UDL or point load. So it will save your time in the exam. So here in this case, maximum bending moment it is given by WL square by 8. Okay, simply this is the direct formula, so you can write in the mains examination directly. That is nothing to worry about it. So put the value small w L square by 8 maximum bending moment. I value we know 7 into 10 power 8 sigma 150 megapascal, and here D by 2, that is 500 by 2, and W, that is W we have to take 50 kilonewton per meter, but to maintain the consistency of unit 50 kilonewton we have to convert into newton, and per meter, so we have to convert into 10 to power 3 because our all the units that you have taken, the stress unit, the depth unit, and moment of inertia unit in mm. So to maintain the consistency of unit we are doing this, and now 10 to the power 3 get cancel out, this will be get cancel out, and sorry. So the remaining thing that you can solve by calculator easily. So when you solve this and take the square root, so you will find L is equal to 8197.5 mm. But you have to write in answer in meter. Whenever in the exam, if there is a length we have to find, then we have to write in meter. So it is 8.2 meter. So this is the answer of the first question. Very easy question, you will get 10 marks easily. Now the second question, very good question I would consider. A solid circular shaft transmit 100 kilowatt power. Okay, so given data you have to write in the similar manner that I am writing. Given data, power is equal to, it is 100 kilowatt if I am not wrong. Yes, it is 100 kilowatt. running at 500 rpm. Okay, now what the other thing that we have given is we have to find the diameter of the shaft. In the question it is given we have to find the diameter of the shaft if the angle of twist in the shaft not to exceed 1 degree in 2 meter length. So the theta angle of twist is 1 degree, that is pi by 180 radian, and length is 2 meter, that is 2000 mm. We are simply writing it. And another condition that is given, shear stress is limited to 75 megapascal. So shear stress is limited to 75 megapascal. Sorry, yes, shear stress it is also 75 megapascal, and modulus of rigidity is also given G, that is 1 into 10 to the power 5 megapascal. Okay, now we have to find out the diameter. So we know the torsion formula, T by J is equal to tau by R is equal to G theta by L. I know the I hope you know the usual notation, meaning what is T, J, tau and R, so I'm not going to explain. So first of all we have to find torque. So torque can be found out from power. Power is equal to 2 pi nt divided by 60,000 if power is given in kilowatt. So put the value over here, 100 kilowatt, 2 pi n is what, 500 rpm into torque divided by 60,000. So you can find the torque, that is 1909.8 Newton into meter. Now we have two equation, T by J tau by R. We can formulate one group here, and another is T by J is equal to G theta by L. So first of all we will find from this group T by J is equal to G theta by L. Torque is 1909.8 Newton into meter. So for maintaining the consistency of unit, multiply by 10 power 3. J is equal to pi by 32 d power 4. G value is 10 to the power 5 megapascal. Theta, that is pi by 180 radian, and length 2000 mm. So when you solve this and do the multiplications cross and side, and take the 1/4 power of the diameter, so you will find out that is 68.71 mm. But the nearmost in practical value we have to take 70 mm. Okay, so mark this aside. Now we have the second condition, T by J is equal to tau by R, or you can say that 16T upon pi d cube. The basic equation that we know is equal to tau. So 16, torque value 1909.8 multiplied by 10 to the power 3 divided by pi d cube is equal to shear stress value, that is 75 megapascal. So take d cube on other side and take 75 on the denominator and take the cube root. So you will get the d value is 50.61 mm. So nearmost integer value is 52. The practical value, that is 52 mm. So now we have two diameter value. So which one we have to consider, 70 mm or 52 mm? So we have to consider the least one. Why? Because if you put the 70 mm diameter over here, then it will exceed the maximum shear stress value, that is 75 mm. Okay, and the angle of twist, sorry, for the factor of safety purpose we have to consider 70 mm diameter, not 52, 70 mm. Sorry, it's my mistake. We have to consider 70 mm diameter. Why? Because if we take the 52 and do the calculation on the rigidity basis, so then we will get the angle of twist theta is less than 1 degree. Okay, that condition, and this also satisfied. Okay, but sorry, this will the 52 mm will not satisfy. Sorry, it's my mistake. The last 1 minute you can consider as a null and void. So we have two diameter, one is 70 mm and one is 52 mm. So which one we should consider? 70 mm for factor of safety. Why? Because if we put 70 in the strength basis, so you will get the working stress is less than 75 mm. And if we put this 52 on the rigidity equation, that is T by J is equal to G theta by L. So your angle of twist will be greater than 1 degree. So this we cannot take. So finally our diameter is 70 mm. Sorry, that is one for 1 minute at blunder. Sorry, it's my mistake. But this is the final answer. I hope you like this solution, and the remaining question will be solved in this similar manner by me or by Srishti madam, but whoever is going to take. So stay tuned with this, and thanks for watching this video, and subscribe this channel to become a part of this incredible journey. Thank you.